Hello good people and welcome back to another math video. This time we're going to be talking about area of composite figures. This is the second video in the composite figures series, so if you have not watched number 1, please go back and watch that first. Alright, let's get started. Just as a quick little reminder, we talked about composite figures as figures that are composed or made up of more than one shape. So in this example number 1, we see a rectangle, but it has this little part sticking out here. So to figure out the area, we could kind of figure out the area of one part first, and then the other part, and then combine them. In this shape, we see a rectangle with a triangle on top, so we would figure out the area of one of those shapes first, and then the other, and add them together to get the total. In this one, we're going to be taking a look at some shapes that are a little bit different. And these shapes are shapes that we might think of as sort of missing something. Like if I needed to figure out the area of this shape, I would have to think about, well, how do I calculate the area of this triangle, and then that part is missing. Or you might be asked to figure out the area of maybe the part here that is shaded. So we have to kind of have a plan for how to do that. Let's get into these. Okay, in this first one we have a rectangle shape, but it is missing a bit of a chunk right here. And we need to figure out the area of this rectangle. So I might imagine this as a regular rectangle, and then I'm going to figure out the area of that regular rectangle first. So let's do that. So I know that the area of a rectangle is base times height, and I have a base here of 12 meters and a height here of 5 meters. So I can say, well, my base is 12, my height is 5. So the area of that whole rectangle is 60 meters squared. That's important. So now we know the whole thing is 60 meters squared. But what about that missing chunk? Well, when I look at this missing chunk, I see that it's a triangle, and I can kind of extend this line over here. And now I'm looking at it as a triangle. I know that the area of a triangle is 1/2 base times height, or base times height over 2, whatever you feel more comfortable with. But I don't see anything actually labeled for that triangle. But I'll tell you this, there's enough information on the drawing to figure all these pieces out. So let's get started. How about the base? Well, I know that the whole distance of this rectangle is 12. And I know that this much of it is 6, and this much of it is 3. So if I have 6, and I have 3, and I know the whole thing is 12, I can figure out what's missing. Well, 6 plus 3 is 9. How much more do I need to get up to 12? I need 3 to get up to 12. So that lets me know that this distance right here is 3. So now that's like my triangle's base. So I'm going to add that in right now on my substitute step for this formula. I know the base is 3. What about the height? Again, the height is not shown, but there's enough information here on the drawing for us to figure it out. The height of the whole rectangle is 5. And there's this little part in here that tells us that this much is 2. So if this much is 2 and the whole height is 5, how much is missing? And the amount that's missing is 3. So that tells me that the distance right here would be 3. And again, I figured that out because I knew the whole height of the rectangle was 5, and I knew that this much was 2. So that tells me that this little part right here would need to be 3. So my height is 3. So now I can just multiply here. And multiplication is commutative, so the order doesn't matter, whatever you'd like to do. You're probably seeing the 3 times 3 first, so we could do that first. And I could say I need to do half of 9. So half of 9 is 4.5, or 4 5/10. And that would be meters squared. So remember, this one is a little tricky because I'm not actually going to be adding these. I have to be taking this away. Because remember, that part of the rectangle is what's missing. So to figure out the actual area here, I'd have to take my 60 for the whole thing, and I'd have to subtract that 4 5/10 for the triangle. I'm going to add a decimal point and another 0 so that my decimal points stack up here. Can't do 0 minus 5. I need to borrow. And borrowing across is 0. Now I'm set. 10 minus 5 is 5. My decimal point. 9 minus 4 is also 5. And 5 minus nothing is 5. And so there is my final answer, that the area of that shape is 55 5/10 meters squared. In this problem, I'm going to say, what is the area of the shaded portion? So we have this whole rectangle, but there's another rectangle on the inside of it that's not shaded in. So we want to know just the area of the shaded portion. We're going to begin by figuring out what's the area of the whole thing. And I'm going to use my area of a rectangle formula. Area is equal to base times height. So area is equal to 12 times 8. There's my base of 12 and my height of 8. 12 times 8 is 96. So I know that the whole thing is 96 square meters. But I have this part right here that's not shaded in. So I want to remove that, kind of take that out of the area of the whole thing. And this is another rectangle, so I can do another rectangle formula. Area is equal to base times height, and this one has a base of 4 and a height of 2, which gives me an area of 8. So if I just take the area of my original whole rectangle, 96, and I subtract that 8 out, 9 becomes an 8, 6 becomes 16, 16 minus 8 is 8, 8 minus nothing is 8. So for my final answer, I would have 88 meters squared is the portion of the shaded rectangle. Alright, here's a funky one. So we have this shape, and again, the first step is for us to look at this and break it up into some other shapes. This is going to be, I think, the first one that we're going to break up into 3 shapes. So hopefully you see kind of an obvious rectangle here on the bottom, sort of like this portion. But I'm going to draw a dotted line here. So I have this triangle right here. Then I have this other triangle over here, and of course the rectangle on the bottom. So I'm going to label the rectangle on the bottom shape number 1. I'll label this triangle shape number 2, and this triangle shape number 3. And let's get started. So for shape number 1, this is a rectangle, so I'm going to do my area is base times height. The base is clearly given as 16. And the height, it's not written over here on the side where we usually see the height, but it is shown right here in the middle. So my height is 8. And if I multiply 16 times 8, I get 128, and that is meters squared. So I now know that my rectangle is all taken care of. That's 128 meters squared. Let's move on to the triangles. So I'll move on to shape number 2, and that's a triangle. So I'll put in my area of a triangle formula, 1/2 base times height, or base times height over 2, whatever you want. Now, let me think about this. There's not too much that's given here. Oh, I do see a base of 6, so that's helpful. Let me substitute that in. Base of 6, but the height I don't see any height here. Let me think about what I do have. Well, this portion is given as 12. And this much is given as 8. So if part of it is 8 and the whole thing is 12, then I can subtract the 8 and the 12 to figure out that this portion right here would be 4. So I now know my height is 4. And here I can just multiply straight across, or do whatever you want first. 6 times 4 is 24. Maybe you see that first. So now I need to do half times 24, or half of 24, which is 12 meters squared. So that was my area of shape number 2. So area of shape number 3. This is also a triangle, so I can start out with my area of a triangle formula. I don't have a whole lot given here. In fact, if I look at this triangle, there's nothing given. I don't have a base, and I don't have a height. But I'll tell you, there's enough information here to figure it out. So number 1 is, let's think about the base. I know that all the way across this rectangle is 16. And I know that this much is 6, and this much is 6. So 6 plus 6 is 12. So that tells me that this distance right here is 12. And I know the whole thing is 16. So to go from 12 up to 16 is 4, or 16 minus 12 is 4. So I know that the base is 4. So I'm going to substitute that in right now. How about the height? Well, the height here, again, it's not given over on this side. But remember when we figured that out over here? 4. And we figured that out by understanding that the height of the rectangle was 8 and the height of the whole thing was 12. So that means that this little leftover piece here must be 4. Now I can just multiply with whatever I feel comfortable first, probably the 4 times 4. So 4 times 4 is 16. Then 1/2 times 16, or half of 16, is 8. And I'm working in meters, so that's going to be meters squared. So now to get the area of the whole thing, I just need to add up the 3 areas that I have figured out so far. When I look at these, the easiest one for me to add first would be the 12 and the 8, because I know that 12 plus 8 is 20. And then 128 plus 20 is 148. So there is my final answer. The area of the whole shape is 148 meters squared. Okay, so we did one where we were sort of missing this triangle chunk. We did another one where most of the shape was shaded in, but we had this other piece that was not. And then we just did one that had 3 different shapes, and we had to figure this out and put them all together. So you're getting to be a composite figure pro at this point. So hope that helps. You can watch it a few times, and we'll talk to you soon.